This video is going to start the giant word problem on page 3 of your packet, and this is very, very similar to the question that you'll see on your Chapter 9 test, and this is what the word problem starts with. It says, your school wants to take out an ad in the yearbook congratulating the girls' swim team on a successful season and for winning their 32nd state title. I think now this year it's 33 state titles, 34. Oh wow, so I need to update that. Shown on the right, this picture is the layout of the ad for the newspaper, and then it says the area of the team photo will be half of the area of the entire ad, and that's something that we need to definitely pay attention to. The photo is going to take up half the total ad space, and so let's find the area of the photo, and if we double it, we'll get the area of the entire ad. So your photo has an area of 6 by 11, which is 66 inches squared. But if the ad has a photo that's half of it, that means the total area will be 66 plus 66, which means the total area, or 66 times 2, is 132 inches squared. And that's going to be important for us to use in our equation down here. Now looking at this picture over here, it says there's going to be this dimension of x given up above your photo, and then a dimension of x on the right side of the photo. And so the total distance from, let's see which one I want to do first, from this point on the rectangle to this point is a total of 6 inches. And if I add this little bit more, that means the total width of your rectangle will be 6 plus x. And if this distance from here to here is 11 inches, and then I add an x, that means this total distance, the length of the ad, will be 11 plus my x. So now I know the dimensions of the entire ad because I'm adding a little bit. It looks like there'll be some probably writing around the picture. So the length of the ad, the total ad, not just the photo, but the ad is going to be my 11 plus x. And the length of my width of my ad, the entire thing, not just the photo, but the whole thing, will be 6 plus x. The entire ad would be length times width, so I'd have 6 plus x times the quantity 11 plus x. Excuse me. Oh, excuse me, I thought I had to sneeze again. Okay, write an equation then that models the diagram above. If the photo, if the area of the photo is half the area of the entire ad. Now this is what I was talking about in the very beginning, where I'm going to need to use that 132. So if I have the dimension of my width is 6 plus x, and the dimension of my length is 11 plus x, that's my width and that's my length. The total area of the ad is what we found in the very beginning, 132 inches squared. And this is the polynomial that I'm going to use to solve. My next question says solve for x and find the dimensions. So this is going to be a two-part process. So we need to first solve for x and then plug it back in to solve for the dimension of the ad. So what I'm going to do is take this length times width equals my area, and I'm actually going to multiply now those two quantities, the 6 plus x and the 11 plus x. So if I have 6 plus x times an 11 plus x, oops, let me rewrite that because I just messed up. 11 plus x. It might be helpful if you guys remember when we were doing Chapter 8 to do the box method, or if you want to do distributive method, whatever you're more comfortable with, go for. So I'm going to show you the box here, just I haven't done a box in a while. So 6 plus x and an 11 plus x. If we multiply these two together, this is what we're going to get. 6 times 11 is 66, 11 times x is 11x, 6 times x is 6x, and x times x is x squared. If I combine my two like terms, the 11x and the 6x, this would be my polynomial. And x squared plus a 17x plus 66, and that will equal our 132 inches squared for the total area of the ad. Now I need to solve for x, but when I'm solving, to solve, you have to have your function set equal to 0, which means I have to subtract the 132 to the other side of the equation. So now I have x squared plus 17x, and then 66 minus 132 is negative 66. Now that I have my polynomial set equal to 0, I can solve. And here you have some choices. You can factor, you can do square, well, this one you can't do square root method because you have a middle term. I wouldn't recommend the completing the square method because your middle term is not even, but quadratic formula, in my opinion, because I'm trying to think of numbers that multiply to make 66 and add to make 17, I'm thinking through my head. I can't really think of them off the top of my head. So because factoring looks too hard for me, I'm going to go right to quadratic. So if I do the quadratic formula, x equals opposite of b plus minus square root b squared minus 4ac all over 2a, now I can use my new formula, now that it's set equal to 0, an a of 1, a b of 17, and a c of negative 66 inside that quadratic formula. So let's start with the discriminant, which is what goes underneath of the radical. My b squared would be 17 squared minus then 4 times a times c. You're going to have to use your calculator, and if you type this out on the calculator, you're going to get an answer of 553. This number is going to go underneath that radical. So as I'm filling out my quadratic formula, my solutions, my x solutions are going to be opposite of my b, so negative 17 plus and minus the square root of 553, all divided by double my a, so double 1 would be 2. Using your calculator, go ahead and find the decimal for 553 as taken as a square root, and then take negative 17 plus that decimal, divide by 2. Take then negative 17 minus that square root and divide by 2, and you'll get your 2 answers. You're going to get these 2 decimals, a 3.26 as a solution and negative 20.26. But as I'm looking at the photo up above, what makes most sense to add to my x would not be a negative 20. And so this negative 20.26 solution doesn't work for our word problem. So the dimension that we're adding here, this x distance, is going to be 3.26 inches. So solve for x. X is going to be 3.26. And then if I plug in the 3.26 for my length and my width, if I find the dimensions of my ad, all I'm going to do is add 3.26 to that 11 and 6. So my dimensions are going to be, for my length, 11 plus 3.26, and for my width, 6 plus 3.26. You can use your calculator or probably do this in your head, but this will be 14.26, and this will be 9.26. So we solved for x, and then we found the dimensions of the entire ad. Nice job. We have one more question left on the review packet, and this one is kind of a reflection from what we did back in chapter 8. And what it says is describe and correct the error in factoring this polynomial. And they have x squared is equal to 9, and then they move that 9 back over with the side that the x was on, so they subtracted 9. And then the factoring here is where there's an error. If you have a difference of 2 perfect squares, x squared minus 9, the correct factors would be x plus 3 and an x minus 3. So the error was they used a wrong sign. They should have had alternating signs, one plus and minus, and here there's only a minus symbol used. So the correct solutions would be when we set x plus 3 equal to 0, so x will be negative 3, but my other factor, if I set x minus 3 equal to 0 and solve and I add 3 to both sides, x could also be positive 3. So the correct answers would have been negative 3 and positive 3.